Hello YouTube, this is part 3 of how to build a Raytracer from scratch in C++. So last time we talked about how the ultimate goal of a Raytracer is to produce an image, and how they do that is they loop through each pixel, they look into the scene and determine what objects are behind that pixel, and they try and figure out what the color of that object is and return that color to the pixel. And then once we have a color for each pixel, we want to save those colors in an image. How we do that is we write a function that takes in the file name, the width and height of the image, and a data type which has red, green, and blue values. But before we do that, we need to include some headers because these object-oriented concepts require some other libraries. But in order to prevent from having to add headers each time we include a new concept, I'm going to go ahead and add all the headers that we need right now. Some of you more experienced programmers might know what all these do, but I just remember having various bugs and things that I had to figure out along the way, and including the right header fixed the bug. So some of these headers might not be necessary, but I'm going to include them because they're not hurting anything and they work. Now we have all the headers that we need, and now we need to create a data type for our color as a red, green, and blue array. Typically in any type of graphics where color is stored in red, green, and blue. And now we're ready to write our function to save the image. This is a rather intimidating looking function, I'll admit, but once we have it finished, you won't have to worry about what it does. We'll just use it and call save BMP anytime that we need to. And you won't have to worry about how it works. I'm just separating them so that I know how many I've done. I'm going to go ahead and compile it, make sure that I don't have any errors. Good. ahead and compile it again, make sure there aren't any errors. Good. Last line. Okay. Let's compile it, make sure we don't have any errors. Yes. Okay. So, what we have now is a function that we can pass color data to that spits out a real file onto the hard drive. So how do we use it? Well, we need to define a few more things in our main function. First of all, we need to define DPI 72. We need to create a instance of RGB type. Wherein is the total number of pixels in the image. We need to define another variable called this one, where this one is an indexing value that's going to change as we go through our pixels, and it's going to be a value that we can use to determine what the pixel at that the x and y coordinates of an individual pixel. I wouldn't worry too much about that. Okay, so at this point, if we assigned a color to our pixels value and then sent that value to our say bitmap function, we would create an image of that color. Let's just make up a color. So what this is doing is it's going through every image in the pixel, every pixel in the image, and then assigning a color to every single pixel, and it's the same color. So what we're going to get is a image of a solid color of these values. If all goes well, we should be able to compile and execute and have an image in our directory. Compiled good. And when we execute rasterrain, there should be a file created underneath it. Well, yeah. And there it is. That's the color that we chose arbitrarily. Now let's do something a little bit with this. Let's restrict the color to the center portion of the image while making the background black. And we would do that by putting an if statement around this. Where if x is greater than, say, 200 and x is less than 640 minus 200, which would be 440, and if y is greater than 200 and y is less than 480 minus 200 would be 280. So we're going to assign this color to a restricted portion of the image and let the rest of it be black. Where the red, green, and blue values of black are all 0. And this should create an image with the center portion colored and the rest of it black. Let's see if it worked. And it worked. So I hope this has been a good tutorial for you guys. And in the next video, we're going to extend our Raytracer to start thinking about things like the camera, the light, the spheres, the floor, and all that other great stuff. So stay tuned for more. Thanks.